All right, so here's part 2. We'll do this quick, hopefully before the bell rings. Similar to part 1, I won't do every single question, and there's multiple parts to this, but pretty much it's the same. You can just plug your numbers in and solve. So, lady standing on a bridge, okay, drops a rock. Oh my goodness, just like before, drops a rock. What's that mean? VI equals 0. All right, so just like before, list out what we have. Standing on a bridge. Okay, what is the magnitude of the velocity of the rock after it falls? All right, so after, we're looking for a final velocity. Time, they say, is 4.2 seconds. I know from before, if it's dropped, that means your initial velocity is 0 meters per second. And of course, I'm on the Earth, so A equals negative 9.81 meters per second squared. Grab my reference table. Find the equation that doesn't have D. It's VF equals VI plus A times T. Now, of course, all this stuff here, you got to show your work. So that means an equation on your little checklist. It told you. I only have 5 minutes to go. So it told you. Got to include the equation. You lose a point. There's 3 things you have to do. Then you have to substitute in with units. So that would look like this. VF equals 0 meters per second plus negative 9.81 meters per second squared times your 4.2 seconds. That's with units, and then your final answer with units, which would be negative calculator. Negative 9.81 times 4.2. Negative 41 meters per second with units. Again, you need 1, 2, 3 just to earn a plus 2. If you don't have one of those, you only get plus 1. If you don't have 2 of those, you get plus 0. If you don't have 3 of them, you get plus 0. Okay, it's tricky. Next part, it says how far does it fall? So they need your displacement. Well, all right. So I still know VI equals 0 because it's all part of question 1. I know VF is equal to negative 41. I know A is equal to negative 9.81 meters per second squared. I know T equals 4.2. So honestly, you could use D equals VI T plus 1/2 AT squared. Or you could use VF squared equals VI squared plus 2AD. Just solve for D either time. All right. Question 2. How far, you're going at 70 miles an hour down the southern state. You're distracted. It takes you that long to react. So how far, D equals question mark, do you travel during the time you're reacting? All right, so my speed while I'm reacting is 31.3 meters per second. And my time is equal to 2.46 seconds. I'm not accelerating while I'm reacting because I'm not hitting the brakes. So I want to just use average velocity equals D over T. Substitute in. Then solve for V. There you go. Now the driver sees a squirrel jump out into the road and they apply the brakes, so they have an acceleration of negative 5.5 meters per second squared. So how far will we travel before we stop now? So D equals question mark. My initial velocity is going to be 31.3 because this is all the same question 2. And my final velocity will be 0. So VF equals 0 meters per second because I've stopped. So this was a big miss for everyone. Everyone wanted to use the time it took me to react, but just because my reaction time is 2.5 seconds doesn't mean it's going to take my car to stop. It's not going to take 2.5 seconds for my car to stop. So the equation I want to use is the one that doesn't have T. No, I'm sorry. Yeah, it doesn't have T, so it's VF squared equals VI squared plus 2AD. A lot of people use the wrong equation for this one. They use time. So that's the equation to solve, and you'll solve for D. And now the next one, part C, consider this. So what's your total distance? So you need to take your answer from part A and your answer from part B and add them up. And if that is like 150, then you'll stop in time because you didn't travel 152.4. If that number comes out to 166, you will hit the squirrel. So a lot of people only looked at their answer for part B for this, but it's important they have to look at both because you're going to travel while you react and you're going to travel while you brake. All right, let's try to get the last one in. Explain why when you throw a baseball up, it has 0. And this is because we're changing direction. We're going up. which is positive, and then we're going down, which is negative. So as you go from positive to negative numbers, that's it. This huge miss, everyone put 0, but it's always negative 9.81. Gosh, they printed it on the reference table for you. If the ball reaches its highest point at 12 meters, so the distance is 12 meters, what's your initial speed? VI equals question mark. Well, what else? Well, A equals negative 9.81, and VF equals 0, because I told you that at your highest point it's 0. So now we look, what's our equation with those three variables? So again, the ones without time, that's VF squared equals VI squared plus 2AD. And now the last one, you throw it from this height, and then you catch it at this height. So there's two ways you could solve this. You could use VF equals negative VI, because what comes up most go down. So VI, I think, was either 15 or 17. So VF is either going to be negative 15 or negative 17, depending on what test you took. VI is equal to your answer from part C. Oh, shoot. A is still negative 9.81 meters per second squared, and T is what you're looking for. So you also could have done it this way. D equals VIT plus 1/2 AT squared. And you could have used 0 meters as your displacement, because it goes up and it comes down to the same exact spot. This equation would have been VF equals VI plus AT. All right, so that wasn't the best explanation, but I've recorded. Oh no, it's not even totally here. There it is for what I was saying before. Screenshot it. I've recorded these videos so many times and the audio is failing. So if this audio works, I'm not going to redo it. I'm sorry. You can come to Homework Helpers or ask me more questions later.